Okay, good afternoon everyone. My name is Liang. So I'm from the StarFive software team. So it's good to get software guys to talk like how we optimize the software, what we learn, all the challenges we've been done for the last 3 to 4 quarters, right? Then the most important is that how we make all these learnings, we share the patches to the main line, right? Then the next thing is we feedback to the hardware guys, right? We might see how we improve this, what kind of extension, what kind of spec we want to push, right? So with that, maybe it's good to give you some introductions, right? So actually, we work with our partners, right? You can see our VisionFive 2 board, right? We also work with our partners. They build the laptops, they build the tablets. We've been hearing a lot of feedback from them, like what kind of things, all that kind of challenge, right? So one thing as a software guys, my team and I, we've been seeing a lot of challenges, right? A lot of software being used to be optimized for other architecture. When we move it to our RISC-V, we found that a lot of things doesn't work for performance, right? They try to compare that, hey, this thing works very well in ARM, right? But why not it's not working in the RISC-V, right? So that's why I think this is some of the things we do, we learn, and the most important, I think we upstream, right? You might notice StarFive, we upstream almost 80% of our kernel today, and we continue to do that, right? Because it's good to get all these learnings back to the main lines, everyone benefited for the whole RISC-V community, right? The most important, I think people would want to know is that, hey, all these learnings and how we want to take advantage of the new extension, right? A lot of things when we do this, we found that there's some extension is not there, but it's in today, right? All this can be very good in tackling all these kind of challenges today, right? So that's why I will show some data, like how we use the new extension, how this improve the whole software today, right? Okay, so this gives a whole overview. So the first part when I talk to optimization, it will be primarily more on the software, right? When you try to do this, you try to create your own distro, you will see what kind of challenge, we share that, how we do that. The most important, I think, is more on hardware optimization, right? How we want to take some of the new extension, how we want to do that, right? So by doing that, maybe it's good to give you a good example. So on the left side is actually what we did once we have the VisionFive out. In 2 months' time, we get the Debian works, right? But we almost spent 2 to 3 quarters to improve that performance as what we get on the right side, right? So maybe I'll let you guys to see the difference here, right? So you can see on the left side, the video is playing at the same speed, okay? But you will notice because the left side, the whole thing's, the burden overflow the whole processor. It kind of changed the timestamp. You can see the whole video play much slower, right? So that is something what we managed to get it work, but I don't think it get the performance what we want, right? So we do a lot of performance tunings, and I think the right side is I think what we have after 3 quarters to get it works, right? So you might wonder how we do that, right? So one thing is that because we have that kind of chip that we don't have this new extension, the SVP PMT things. So what happens is that when we have a driver, you're not able to say that some of the page table or the page properties I want to cacheable, non-cacheable. In our driver, some even driver from vendors, we found that, hey, you whether make holding cacheable or holding not cacheable, right? So if you as a software guy, you know that if you want to move the whole huge data in the cache, it moves faster. But sooner or later, it will trash all your execution cache. Your processor will get all this kind of impacted, right? But if you move everything in non-cacheable, yes, it's very slow, right? So that's why in the chip what we have today in the VisionFive, we don't have this extension. This is kind of added. So what happens is that we have to change the driver, the vendor driver, to take advantage of this, right? So we have to make it work, right? So it make it works, but we have to hack a lot of the code to get it works, right? So that's why we believe that with this new extension, this will help a lot, right? Second part, if you try to play a video, it will go through the whole process from the video file, you go to video processing, you go through a GPU, you go through a display, right? So you saw the left side, the right side of the video, you can see the thing is playing very slow, right? So the first thing we want to find out is that where does the whole thing go wrong? We run through the whole profile, we want to check the hot things. We found out that actually the mem copy does take a lot of times, right? Because I think it's not really optimized. So what we do is that we go through all the codes to see where is the mem copy. So the first thing you will want to do is to remove those mem copy, right? So that's why we found that because the driver, the way how it handles the interface, some driver might do a main copy to ensure you don't mess up that data before you go and process it. That's why we found that one of the places that we can remove is between the FM pack and the video processing unit. We remove that, it improves, right? And you might wonder why we don't remove that in the GPU, right? Because we don't want to break the whole OpenGL. If we break the whole things, the application doesn't work, right? Because if you get our VisionFive toolbox, you get the Debian, you can see we want to get the Firefox running. We want to get LibreOffice running. We want to get the game running. If we go hack the whole OpenGL, what is the disaster? All the application doesn't work. You have to port that, right? So this is a no-no for us, right? So that's why I think for our case, we do retain that main copy because for the this OpenGL kind of way of doing things, but we managed to get remove the FM pack. It does improve, right? This is one of the techniques we use, right? Then the next part is multi-threading. Actually, we found that because the main copy is quite slow, the Firefox assumed that maybe you have maybe other ISA already fully optimized the main copy because they have a lot store multiple of other things, right? But main copy is very costly when we run in VisionFive, right? We want to improve. You see, we try to remove all this redundant main copy, and we found that it doesn't get the performance. What we do? Actually, we do a parallel. We have 4 threads doing multi-thread main copy, right? But of course, you will know what does the downside. You almost flood the processor with all this, right? Because true, we want to showcase we can play like 1080p, 60 frames per second kind of a video, right? But we are able to achieve that. But the problem is that, yes, it will throttle some of the CPU, right? That's why I think the next slide will show you what we will do, right? So one thing we found that, yes, we will work with hardware guys to how to improve the whole pipeline, improve the whole hardware, how to improve the main copy. But in the meantime, while to reduce that so-called of a CPU loading time, we want to move those big data using the DMA, right? So it means that we are changing the whole main copy to take advantage of DMA when you involving the large data, right? So you want to offload the CPU, but you also want to take advantage of the performance, right? So that's why, in this case, again, we change some of the vendor code. We want to use that so-called main copy with a DMA, right? So you can see, for this generation of product, we need to change a lot of software to get it works, right? But yes, we can demonstrate it works, right? But I think there's a more elegant way of doing things. So that's why I think what we do is we want to take all this learning and we put into the hardware also, right? So this is very important because I think for software guys, we want to optimize the software. We want to make sure the software hit all the ecosystem, broader adoption, those kind of things, right? But one of the things that software guys should do is also feedback to the whole hardware things, maybe the ISA, the new extension, how we want to do that. So that's why we come out our own in-house kind of a processor. We call it Dubay 90 and Dubay 80. So Dubay 90 is a performance core, and 80 is more the efficient core, right? So we go and tackling those kind of performance issue, like how we want to improve the whole pipeline. That's why the 90 is almost like spec-in 9.4. It's almost A76 equivalent kind of things, right? We also add like few new extension, right? And throughout the whole enablement, we found that like security is a big thing, right? A lot of folks have been talking about the security stuff, right? So these are the few cool things we add into our core, right? So today, we've been running some data to see what does this improve, right? There are a few kind of enhancement we do, right? But we are, in this example, I'm trying to put some common, like B extension, right? B extension is pretty much standard today, right? So to our case, we found that by just enable the B, you use the full B, ZBA, ZBB, those kind of things, right? It will give you quite tremendous improvement. Like one thing, you have application involving a database, right? It almost double up the whole thing, right? Another is the compression, decompression, right? You want to do a zip file, compress all those things, which is common you do in the Debian or in the laptop, those kind of things. This does improve, right? So that's why we believe that this is some of the good example where the new extension able to help in terms of performance, and it help a lot of software guys, right? We don't need to hack the code to get all the performance, right? And another one is better example is the FM pack. If you want to deal with multimedia play, all these things, you will use FM pack, right? FM pack, how to improve that, right? In this case, we use the vector, right? We know that vector is good, right? But we are giving you an example like how vector does improve and come to video playback, right? So in this case, we try to get those H264, the ABC kind of encoding and decoding things, right? And you can see the 5 function here is not the 5 best performance function. To make it more realistic, we took these 5 functions are the function who took the most cycle in the whole these ABC things, right? So you can see by just turning on the vector with some slightly tuning on the code itself, actually you can go 2x and 4x, right? So this is one of the part that we say that, yeah, with the right extension, the whole thing will improve. You don't need to hack around the software code, and this is some of the stuff, right? So this is some of the things, improvement we are doing, right? So some of the code tuning, maybe some of the FMPEG library we enhance, right? This is something we will also share back to the whole community on that, right? So last but not least, one of the things we also push hard, some of my colleagues just share on the Monday, right? We talk about this because you might oversee like StarFive been pushing this power management. So if you want to make a laptop, you want to make a mobile things, power is another important things, right? So how to take that? Actually, other ISA is addressing that. They use a heterogeneous core with a performance core and the efficient core, right? So we've been doing this. We also have to make sure the EAS, the energy aware scheduler, does work with this, right? So you can switch the core if you want to go for performance or go efficient, right? On top of that, we also have this coherent, we call it starring, the coherent interconnect. This is also something we built in-house to make sure that, yeah, it works for both core, it works in the most best performance manners and those kind of stuff, right? So this is something we are roll out on the next generation. This is something we want to do more kind of a mobile, battery-sensitive kind of application, right? So yeah, this is some of the things we will enable more, like besides what we do on the Debian today, right? And we will continue to use this platform to see what we can optimize from the software side of things, yeah. I think that concludes my presentation today, yeah.
We have 4 minutes for questions. Any question? Questions? Oh, one question there.
So when you're making changes to the vendor code for the GPU drivers, is there a mechanism that you're working on to try and make that easier for end users to be able to take those updates across operating systems, like doing something like NVIDIA does, where there's a binary blob, but there's like a DKMS wrapper so you can get it loaded up more easily?
Yeah, that's a good one. Because I think some of the kernel changes we do, actually we do put it on the public, we even upstream the things. But some part, you roughly know, is kind of confidential. It doesn't ever like to do that, those kind of things, right? That's why for us, you might read through that we try to push an open source kind of a GPU driver, those kind of stuff, right? So everyone can involve and we can put all these learnings back, right? So today what happened is that we do have some binaries, like for example, like we work with other distro, we kind of say, yeah, just adopt this binary and this is how we kind of do things because the whole legality things, yeah. So it shows that, yeah, we're looking forward like to have an open source GPU where everyone can contribute and benefit, right? Yeah.
Thank you.
Yeah, thank you.
More questions? Any more questions? Okay, I think that's it. Thank you very much.
Thank you.